Go. All right, here's what we're going to do. We're going to test this model right here. We have two mediators, two dependent variables, three independent variables, and their interactions with two moderators and some controls. I might not get to all of the additional pieces, but we'll do some mediation, some moderation, and all that. Okay.
What was frequency of use?
Frequency of, yeah, let me explain the data real quick. The data is, we collected data on how people use Excel and whether the way they used it affected stuff like whether they thought it was easy to use and useful, and whether that led to anxiety or joy. This isn't the model I actually published. This is a terrible model, but it works for an exercise. So we collected a whole ton of stuff. I actually had 5 models proposed to test, and this is one of them that works, I think. Okay. So I should explain. Design fit is how well does the technology fit the task that you're doing. Habitual use is how habitually do you use the software. Skill acquisition, to what extent do you believe using the software leads you to become better at stuff, better at your work. Perceived ease of use, how easy is it to use. Usefulness, how useful is it. Do you have anxiety from using it? And do you find joy? These are sort of opposites, right, to some extent. Do you find joy in your use? Frequency is how often do you use it. Gender is whether you're male or female, obviously. And education, age, and experience is how long have you used it, for how many years.
Usefulness is my perception of how well it solves the problem I want to make.
How well does it help me perform my tasks?
And obviously the top one is, do I have to think a lot about it?
Yeah, is it difficult when I use it, or is it easy? Yeah.
And James, we'll have the survey instrument as well.
Yep, you will have this. These are all the items with their questions. Sorry, with their wording and their definition. Yep, and they're all on 5-point Likert scale. Okay.
You said 5-point.
Yeah.
They all are.
All right, let's go do this. What should we start with? Here, we should start with the data. Here's the data we're going to give you. This is actually the exact same data you're going to use for the capstone. Just I'm using different constructs. So here's the data we're going to give you. There are 300 data points. First thing we need to do is see if there is missing data, right? Okay, so let's find missing.
SPSS, huh?
SPSS. Yeah, analyze, descriptives, frequencies. Just throw it all in there. Well, it's only the stuff we need actually, sorry. So we don't need comp use, ATIP use, we need habit. And skill, and useful, and design fit, and ease of use, and joy.
This is also true for the capstone, right? We only do data.
You only need the data. Yep, exactly. Just on the stuff you're using. And anxiety, right? I don't think I missed any. Although we should look at gender, age, education, frequency, and experience. Okay, throw those in there. Statistics, what do I need? I should, as long as I'm at it, look at skewness. Kurtosis. We don't need to look at skewness because these are Likert scales. So there's, really you just want to see is there variance on the scale. We don't need to look at outliers because what's an outlier on a Likert scale, really? Continue. That should do. Hit OK. And this table right here is the one I want to look at. I'm just going to copy this over and stick it in Excel. And I want to see, is there anything here that is not a 0? This one is. Useful 2, we're missing one. Oh, and useful 3, we're missing one. Let's see, and a few others. So what I should do is just conditionally format this maybe. Highlight greater than 0. There we go. Ooh, there we go. And I think I'll just get rid of anything that is not a problem. Come on. There we go. We have 4. These guys. Where we're just missing 1 on each. It's probably from the same guy, is my guess. So what do we do with those? Useful. And so we'd report this, right? We'd say we screened our data. It turns out we had 4 missing data points. What do you do with those? Usefulness. We can impute these, right? Because it's just on the Likert scale. Age, we could probably also impute. Experience, it's on a bigger scale, but yeah, we could probably impute that as well. I would just impute them, because it's only 1 point. It's not like we're missing a ton of data. I'd go ahead and impute these. Or you could throw out that record. If it's the same person, throw out that record. It's up to you what you decide to do. You just have to justify your decision. So, you know what I'm going to do before I do anything? I'm going to save this as a different data set. It'd be bad if I wrote over your capstone data. Workshop. Phew. Okay. And I'm actually going to go get rid of anything I don't need, because it's just cluttering things up right now.
That would be any of the variables that aren't noted in the model, is that correct?
Yep. And that's why you save first. Let's see, useful, design, fit, ease of use,
Does that mean
joy, adopt.
how about
Efficacy, did we have that one in there? I don't think so.
no?
Nope.
Now, Jane, for the
Probably.
initial model that we get on Saturday, will it have
There we go.
just the ones that are the variables?
Nope, it'll have all this,
It'll
I
have
think.
those, so you have to take them out.
Yeah. You don't have to, it just makes it easier. All right. Okay. So let's go and find those missing data points. That was useful 2 and 3. Here we go. Useful 2 and 3. Just gonna scan real quick. Here's one missing one. It's not on the same person, it looks like. So I'm just gonna impute data. Impute. Replace missing values. Transform. And it was useful 2 and 3. And age and experience. Age and experience. And for this one, I want to use the median of nearby points. How many points? All of them. And I'm just going to call it the same thing, so it just replaces the existing
That's
variable.
why I didn't do that.
Yeah, there we go. Otherwise, it creates a new variable.
A new column. Oh god. No.
Median. You always use the median when you're replacing Likert scales, because a 4.35 on a Likert scale is kind of weird, right? So replace with the median. For age, we can replace with the mean. Oh, whoops, I didn't hit change. Median of nearby points, all. Change. Age, we can do mean. Yep. Change. And experience, we can also do mean. And hit OK. It's going to replace existing, yes. And it did. We now have no missing variables or values. Excellent. Next, kurtosis. We did an output for kurtosis. Here it is, right here in that same table. Let me copy that over. Paste it over here again. Okay, we're looking for anything. There are a couple different thresholds we can look at. One of the strictest ones is absolute value greater than 1 for this row here. Escape. There we go. Okay. So we could look at that. Let me do conditional formatting. Highlight greater than 1. Okay. And highlight if less than -1. Okay. And this will give me everything that has some kurtosis. Let me get rid of anything that's not giving me a problem. Just like to clear it out. Don't like it cluttering up. and those guys aren't a problem either. Okay, so there's quite a few, but notice the values. They're not exorbitant. 1.5, 1.5, 1.4. So this is the statistical threshold. 1, you can actually get out to 2.2, I think is the one other published one. When does it start affecting your measurement model? Around 2.8, 3.0. If I saw something like that, oh, here's a 2.8, so that might be a problem. Anything above 3, that's definitely a problem. So,
those are the controls.
yeah, so let's look at the main model here, main effects, and we see there's really nothing above 3. You could argue skill acquisition 1, that's a little high, and maybe design expectation fit 4 is a little high. The rest, I won't even bother. So what would I say at this point? I'd say when we're looking at kurtosis, testing normality of our data, we discovered a few variables with greater than absolute value of 1 kurtosis, but only 2 greatly concerned us. Name the 2 and say what their values were. We opted not to eliminate them yet, but we flagged them for concern. We keep our eyes on these guys when we're testing the validity of our measurement model, doing our EFA and CFA. If they were consistent problems, we're going to kick them out of the family. Okay. The rest of them, I'm guessing these aren't going to be any problem at all. As for age, education, and experience, why are we experiencing such high kurtosis?
We've got different, it's a big flat experience. You've got lots of different people at different ages.
Same ages.
Same.
We sampled students in an undergraduate class, sophomores.
Right.
They were all between the ages of roughly 20 and 22. There were a few outliers. So what I would say at this point is, yeah, we see kurtosis on these, but it's not unexpected kurtosis. Also, we are not predicting anything in our model with age, education, experience. We are controlling for these. I think we might, is experience, let's see, a moderator or no, it's just a control. So, you know what, not a big deal. We're going to leave it in. So we have no normality issues we really have to address, we just have to talk about. Just have to talk about them. Again, don't say we found 2 variables with high kurtosis values and stop there. Say what you did or decided to do. So we're good. We can move on. We've tested normality. If you'd like, you can also test, according to the rubric, we did missing data, we did normality, there's outliers. Do we have any outliers? No, except maybe age, education, and experience. So let's go look at those. Let's do, frequencies of work, except I want to see age, education, and experience. Nope, education, age, there we go. Okay, and I want to see statistics, I want to see cancel, I want to see charts, histogram will work, pie chart will work. I'd really rather see a leaf plot. Oh well, this will be fine. Pie charts, I've never seen. Alright, here we go. Let's go with histogram. Continue. Alrighty. So here's education. Right here. We have one person. Here's the frequency. We have one person who's had 10 years of schooling. Yikes, an undergrad with 10 years. That's my brother. He's graduating tomorrow. He's only been in 9 years. Hope he doesn't listen to this video. All right. Okay, we have 9 with 0 years. This is their first year. They're freshmen. So that's probably fine. They're not really outliers. Mostly 2 years. These are sophomores. Really, the 10-year person might be an outlier. I might bring that up. Say we found one person who was 10 years, and then your executive decision there. Do you lop them off? Are they out? The only reason you would lop off an outlier is if they are outside of your theoretical population. So in the context of using information systems, is someone with 10 years of education not included? No, so we'd leave them in. But you might mention them. We found somebody with 10 years of education.
Since it's in your control variable too.
Not a biggie.
Yeah, so that wouldn't
Yeah.
play in as much.
Correct. Age, 17 years old to 34. Wow. They lied to me. I asked them at the beginning of the semester if anyone was older than me, and they said no. I already turned in grades. I can't punish them. All right, let's see. Okay. So are these guys outliers? Again, they're older, a lot older, a decade older than the majority, but I mean, they're still within our theoretical scope, so that I wouldn't do anything about them. I wouldn't even mention them, honestly. There's not like a huge gap. It's not like all 18-year-olds and then a 50-year-old.
Couldn't you go in to see if you had done this in one of your videos, where you actually looked at the respondents' particular
Yeah.
things to see whether the same person with education is the same person who's older?
Yeah, I bet the person with 10 years is also the person who's like 34.
It turns out it could be a typo.
It might be a typo if it said 14 or like 74, but 34 is a believable number for an undergrad if there's only one or two of them.
So I don't quite understand why we're doing this for controls. Isn't the whole point of controlling to take variation out of?
It's just to know our data, because again, if somebody put 14 years old, that's probably wrong, and we don't want wrong data in there. Yeah. So you do an outlier analysis for that.
Could you show please when you would like to look which person is it? You go to the data icon.
Yeah, I could go look and see. It would be if I did a box plot, I could do that. One moment on that. Experience. We have somebody with 25 years of experience with Excel. Has it been around that long?
Yep.
Yes, actually.
Okay, and let's assume that was the 34-year-old. So they've been using it since they were 9.
Not far enough.
That's a little weird. Let's do this. Graphs, legacy dialogues, box plots. Can I do that? Simple. Summaries for variables, I think. No cases. Fine. And I want to see experience. This is not where I want to be. I want to be here. Analyze, descriptives, explore. Okay. And let's explore education, age, and experience. Throw that in there. And plots give me... Oh, thank you. Yeah. Get rid of that. Okay. We're good there. Cancel. Plots. Stem and leaf. I like those. Okay. Where's my box plot? I've lost it. Okay. We'll just scroll down here. Here we go. It's Mr. 93 with 10 years of education. It's Mr. 201 who's 34. And it's 189, 20. You know what we should do? Find out if 189, I shouldn't dig into this so much, but find out how old 189 is real quick, because this could be revealing. 189. How old are you? Age, 21 years old. That was a typo. Okay, glad we looked at that. So what do we do with that? Just give him the mean. That's all. It was obviously a typo. Did he mean to type 5 or 2? We have no idea. So give him the mean, and when you give somebody the mean, it has minimal effect, unless you have very few data points. But we have 300. So what is the mean for experience? I can actually get the exact number here. Here we go. Experience mean 4.4. 4.47. So I'll give him a 4.5.
Isn't that the mean, including 25?
Yes, it is. So, should we look at the median? Yes, we should.
When you
Done,
compute it
yeah.
though, when you compute it though.
Why, he's interesting. Why did it say that?
Ah,
Okay, the experience median is 3. So that we should use the median. Very good. Because 25 years is pulling that mean out, but it's not pulling the median anywhere. So we should use the median, which was 3. Good call. Extra credit.
you did though impute it, to take that 25 out.
Well, you'd have to delete that point first to impute it, and then it wouldn't be there.
You delete it and then you would impute it.
Yeah, you could do that.
You could do that.
Yeah.
Okay.
Okay. We're good. Yes.
How do you describe this process in your?
This outlier looking process.
Yeah, it's sort of
Yeah. It's in here actually, if you want. Yeah, it's in here, and we actually find outliers in this example and explain what we did with them and why we thought they were outliers. So it's all in there. Okay. Back to the rubric. So we've done missing data, outliers, normality. Moving on. EFA, my favorite part. Yes?
Didn't you say save this file?
That's a good idea.
Also, you didn't do multivariate.
Save. Okay. Huh?
You didn't do multivariate.
I can do multivariate, yes.
Oh,
Yeah, I don't have a structural model. Good call, though.
you already know you're going to be doing interaction. Do you want to transform while you're in SPSS?
Me personally? No.
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 Just wait until you're done.
Yeah. Okay, analyze.
James,
Yes.
question.
Yes.
If you are not using the same scale,
Yes.
if you standardize here,
If you're using like 5-point and 7-point?
Yeah.
No, doesn't matter. What you're looking at in regressions, right, is relative distances. So, 5-point to 7-point, we can actually use the same scale, can't we? Or, sorry, we can use both scales and the regression still works.
so you don't need to standardize.
No, and luckily for you guys, it's all 5-point anyway. Yeah. But like age, we can regress a 5-point Likert scale onto age. And age is, fluffy. And the regression still works even though age is on this massive scale. Works for income too, which is okay. Analyze. Factor analysis. Dimension reduction. Where to go? I had this problem before. Extend. It's up there. There it is. But it's not on my screen. To pull it down. That's Lily. She's cute.
She's the youngest?
Yeah, she's the oldest. Alright. So, do we do them all at once? Yes, I will. Because we have 300 data points. Why not? Descriptives. Oh, it jumped up again. Bother. I don't know why SPSS does this. It recalls the position it was on your screen. Even if you had an extended screen. It's really bizarre. Here we go. Okay, reproduced, KMO, continue, extraction. Oh, blast. All right, I'm going to pull them all down. And do this really quick. Continue, rotation. Oh, no. Okay, now they're all here. Okay, sorry about that. Thought I fixed that before it came. Did it for everything except the EFA. Extraction. Maximum likelihood. Which one do you need to use? It's up to you. Based on eigenvalues, I'm going to start with that. We have 1, 2, 3, 4, 5, 6, 7 variables or constructs we expect, but I'm going to let it flow freely.
You already found some concerns with kurtosis. Wouldn't you want to use maximum likelihood then?
We're going to use maximum likelihood in Amos anyway. Know what I'm saying? So I'd like to stay consistent. Will maximum likelihood hide the kurtosis? No. What we'll end up seeing is just lower communalities, most likely, with those values. or those variables. But I won't scream if you use principal components or principal axis factoring. That's fine. Continue. Okay, rotation.
Do you want us to justify which our choices?
On this one, not particularly. This is a minor sort of thing. They all come to roughly the same result. We're looking at structure rather than precise estimates for the most part. Options, I would like to suppress, and I'm going to go ahead and sort by size. Okay. And here we go. KMO, good. Here's the communalities. Yikes, habit 1 is terrible. And everything else looks pretty tolerable. Anything above 0.4 is just fine. It's just fine. How many did we get? We got 8. We only expected 7. So this is a problem. We explained quite a bit of variance, 61, which is great. I'm going to skip that, skip that. We have tons of sample size. We have 300, so, and a pretty complex model. Are we ever going to see a non-significant p-value here? Probably not.
How do you explain that? How do you write that?
We have a very complex model with lots of data.
Okay.
So what it does is it inflates your chi-square,
Right.
and so you're never going to see a significant goodness to fit p-value for the chi-square, or non-significant one. Redundancy, we're actually doing really good, 3%, so that's fantastic. We went less than 5% on that one. And here we are. It actually looks clean, but let's go through it. EOU, good enough. I'm going to say anything above 5 right now, 0.5, probably good enough. Joy, great actually. Anxiety, fantastic. Useful, fantastic. Habit, ugh. Oh, that's terrible. And skill broken into 2. And then design. Design's pretty okay. So our biggest problems right now are habit and skill.
Is that cross-loaded? No.
Yeah, this one down here, skill acquisition, that's just rotten.
Habit isn't.
It's loading on itself though. So here's, what would you do first? If it's loading on itself and that's the only reason we have a second or an 8th factor, let's just push it down to 7 and force it back on itself. That'd be my first approach here. Okay, I'm just going to jump straight down to the pattern matrix. Skill acquisition, lumped together. Look at that. It's not fantastic, but it's pretty good. Probably good enough.
Is habit loading on itself on, I can't see the 7 or 6?
Oh, habit 1 loads nowhere. Okay. That's a problem.
It's too low. Our number.
What that means is habit 1 doesn't correlate with anything very well. It's not even cross-loading. It's just nowhere.
But it could be like 0.2 though.
It could be, because I'm suppressing it.
Right.
But anything less than about 0.5, I'm not even interested in. So 0.2, I'm definitely not interested in.
So, James,
Yeah.
because of the reporting, do you have to say in the report that when you first run, you better...
No, I don't want a travel log.
Okay.
No travel logs. What you need to do is report your final decisions
Okay.
and the final pattern matrix. So you only report one pattern matrix. And we're going to make some executive decisions here that you do need to report. So we're going to make an executive decision to delete habit 1. And you say, we deleted these items because of, and in this case, it didn't load. It's a low loading. So factor analysis. Habit 1, sayonara. Jump down to the pattern matrix. And again, we're just looking at habit and skill.
James,
Huh? What? Sorry.
You are an easy user. Would you delete to get the only to remain the last calculation computation you did? All the other stuff you would delete?
I left everything the same. I just removed habit 1. Is that your question?
No. The factor analysis we did before, on the left, you can delete.
Oh, yeah, I could delete all those if you want. Or this is a record for you.
Oh, it's a-
Yeah.
Would you put the pattern matrix, this pattern matrix, the good one?
The final one?
Into the 30-page front, or is that in the back?
For the capstone, I'd stick the pattern matrix. This is the one table you can copy over. I'd stick the pattern matrix in the 30 pages. Unless you're running out of space, then stick in the appendix. But this is an important table. Okay, skill acquisition habit. We figured out skill acquisition is probably tolerable. Habit is still having troubles. I mean, we want things to average out above about 0.7, so this is kind of a mess. What do we do?
I'm sorry, what you said that average out to about 0.7? What's the message?
Oh, these loadings. So like this set of loadings, they average out to about 0.84, it looks like. These loadings average out to about 0.5 something, which is too low. So this set right here, they average out too low. So the AVE, we want above 0.5, which is the loadings squared with some error in it. And so when you square the 0.7, you get 0.49. Hence, we want everything averaging out to roughly 0.7. Sorry, that was...
Because it wouldn't be clear necessarily that from what we've done in the past that we do anything at this point.
At this point, we have some choices. Executive decisions, again. Is 0.44 good enough to move on? According to Hare, yes, it is. For a sample size of 300, you need a loading of 0.35, I think. Or something like that, 0.3. And it has to be significant when you do your CFA. So at this point, we could just move on. I just want to run some contingency stuff with you so you know what to do if you do run into a problem.
So if we say that we're going to keep it based on Hare.
Yeah, just cite Hare.
Just cite it and say
Yeah.
we kept these two factors based on Hare due to the sample.
Yeah.
Okay.
And I think I referenced that table from Hare in one of my slides that we had for a lecture one day, once upon a time. What would I do at this point, though? Everything's fine except habit. What I would do is throw habit into its own factor analysis with like one other thing. Let's take skill acquisition since it's a mess-ish too. Extraction, not 7. We're going to let it flow freely. Hit continue and go. And so this is just habit and skill acquisition. We see habit 2 is kind of low. Habit 2 was one of the problem ones, right? With kurtosis. Yeah. Everything else is tolerable. Kind of low there. We ended up with 3. We were expecting 2. Three factors. We have 16% issues here. And here we go. Oh, it's just skill acquisition again. All right, well, that's a problem. We wanted to troubleshoot not skill acquisition, but...
So you made a smaller EFA.
Yeah, I'm just making a smaller EFA. I'm going to take out skill acquisition because it has its own problems. Run this again. Jump down. We still get 3. Let's find out why. And habit broke into 2. Here we go. Okay. So naturally, habit 2 and 3, the ones with kurtosis issues, are part of a separate dimension, a subdimension or subconstruct. These ones don't load all that great together either, though. So what do we do?
Why couldn't you have just run habit against itself? Why do you need to use it?
Just in case we ended up with a single factor. You can't have a pattern matrix with a single factor.
Can we go back to the survey and see if those questions are similar enough?
You definitely can. Capstone instructions, habit 2-3 stuff. Let's go up to here.
Enough items within that.
We do have quite a few items.
1 or 2.
It's not going to hurt us that
It
bad.
shouldn't hurt you.
Oh, these are just the items for yours. Habit's not in there. But we can go to, oh, it's in here though. Variable, habit. 2 and 3 was it? And let's look at those. I have already put a lot of time and effort into learning the software, so I prefer to use it rather than learn to use more specialized software programs. That's a long one. Probably just stopped reading is what happened. Same with 1. So long in that we dropped that one. Whereas these other ones are short. Or these other ones. Okay, number 3. I would lose a lot of my work information if I were to switch from the software to a more specialized software program. And then these all look similar. You know, it's amazing how similarity of wording drives similarity of response, even if it's not similarity of content. Keep that in mind when you're creating your own quant surveys. I use the software for many tasks. I use the software. So the issue here is wording. That's why 1, 2, and 3 don't work. Wording. So,
Make a separate item out of it?
You might be able to create a habit A, habit B. Yeah. And that's your executive decision. I'm going to drop habit 2 and 3 and throw back in everything else to see if it works. Let's see. Yes, joy is in there. Oh, it's all of it, isn't it? That's right. Except that stuff. Oh, bother. There we go. That to that. Okay. Extraction, eigenvalues still. Continue. And here we go. Looking at the extraction. Fantastic. It actually went up for total variance explained, and we only have 7, which is what we wanted. Goodness of fit, we're never going to achieve it anyway. But if you look at the chi-square divided by degrees of freedom, it's between 1 and 3, which is what we want. It's actually right in between 1 and 3. 3% non-redundant residuals. And let's go look at skill acquisition. Still iffy, but fine. And habit. Here's habit. At this point, do we drop habit 9 or say good enough? What I would do is do both. Just go do it real quick. Habit 9, adios. Run it. Pattern matrix. Habit. It didn't really help, I don't think. It actually dropped some of those loadings. I'm going to throw habit 9 back in. Habit 9. Just drag it right to there. Hit OK. And this is my final pattern matrix. And so at this point, I report I dropped H1, 2, and 3 due to conflicting wording with the other items on that construct. Therefore, they did not load together.
James, when you said about the wording, we have to be aware that the wording are similar or not similar.
It was not similar. There was a very similar structure and wording for habit 4 through 8, but habit 1 through 3 was not following that pattern.
Okay.
Yeah.
This would really depend on what you were trying to access with the question. Because
Yeah.
it measured something, it just didn't measure what you wanted it.
Exactly. Yeah. But we also saw that habit 1 just didn't load. I mean, just didn't load anywhere. And so there were issues there, probably due to the length of the wording. All right, that's EFA. Woo! Now, what we're going to do is use my handy dandy little pattern matrix model builder thing. I'm going to copy this, go over to Amos, see what I had up last, this nasty thing, and let's create a new one. Okay, new, add the data. Temp stats charity. Look at all these data sets I have. This is just in the past, not long actually, since September, late September, all the people I've helped, with their data. Okay, let's see. And that doesn't include you guys. Let's see, 2014? Capstone Data Workshop. Okay. And plugins. Pattern Matrix Model Builder. Paste it in there. Create. Just saved you an hour. You're welcome. Plus troubleshooting.
Yes.
Yeah. Oh, look at that. All right, go rename it real quick. Yeah. Ease of use. Have you ever had to live without it, or have you had it the whole time? Oh, you're so lucky. Oh my goodness. Oh.
James, side question. Tony has us over here change the variance, put this to variance of what's the sun structure variance of 1.
Oh, and remove the path constraint. You're welcome to do that as well. I'm not going to, but you're welcome to.
Same result.
Yeah.
Okay.
Essentially, yeah. This is anxiety. Useful. Skill. Habit. And design expectations fit.
James,
Def.
in terms of naming, can you use abbreviation instead of
Can you use a what?
shorter form?
Oh yeah, that's fine. As long as you know what it means. And as long as it's somewhat semantic, yeah.
Hey, James, what Tony Sommer told us to standardize or not. Can you show us how to do it?
Yes.
To remember?
Standardization?
what
Standardized variables, values.
Johannes was saying before.
What's that?
Tell me when we get there.
What's Ted saying about can you?
He was talking about scales, standardizing scales.
Oh, in interactions.
I asked him the question earlier, get to when the only time that you have to standardize.
Yeah, we'll get to that. All right, let's save it as recent places, 2014. Here's some stuff. Let's say CFA initial, because we haven't done anything to it yet. Saves and give me some output. I want standardized estimates and modification indices, but really I only care about those ones over 10 at this point. Yeah.
Why do you say 10?
Because it's a very complex model with lots of data, so that it's going to inflate the indices, because the indices are based on the chi-square. So I just did one with, I can't remember who it was. Oh, it was Tim, different class. And we set the threshold to 100, because all of his indices were like huge. Did one with Naoki. He had a sample size of 10,000, and so we set it to something like 10,000. Okay. Run. And spot check it. And standardized. And I don't know if you can see these, but they're looking good, looking good, looking good. We're looking, again, average over 0.7. Looking good, looking good. Not fantastic. So, let's do some stuff. First of all, let's check the modification indices and see if there's a clear loser. Modification indices on, is it, habit is E32 through 36. So, E32 and 34 have issues. All right, 32 to 4. Let me go ahead and do 32 and 34 real quick and see if that helps anything.
Excuse me, could you tell me again what we're actually measuring from modification index? You said that's off the chi-square, right?
Yeah, the modification index is saying what changes could you make to the model to improve your chi-square, to minimize your chi-square.
I see.
Yeah, we're essentially improve model fit.
And when you correlate, you can only correlate error terms that are on the same construct.
For the most part, that's a good general rule, although Dave Kenny says there is an option if there's very similar wording between, let's say, anxiety 4 and habit 4, or something like that, they're worded almost identically, then there's a systematic correlation that has nothing to do with the concept. And so you can correlate it to account for that systematic correlation. And run it again, see if it helps anything, and maybe a little bit, but look at this. Habit 6, let me zoom in here. Habit 6 has a loading of 0.44. We didn't see that in the EFA. Habit 6 was fine in the EFA. So let's go ahead and drop habit 6. And that's just an executive decision. We say we dropped it due to low loading. Run it again.
The justification is it's just not it's not discriminative enough, right?
It's not convergent enough.
Convergent.
Yeah, it's not convergent enough. And we're at this point now where it's pretty close. We are still averaging less than 0.7. I would save it at this point and then delete that top one. That's 0.57. That's borderline. I'm going to go ahead and delete it just to see if it does help us. We still have three items. I'm going to throw in this constraint I just got rid of. Run it. And if that didn't work, I'll just go back to what we had. They're decent. Let's go ahead and run an analysis on this. Oh, I can show you the new one. We created a new one. Yeah, what?
You said yes, I can show it, yes. So I have a question, I just thought of it.
Mm-hmm.
In this case, if you had space
Uh-huh.
in your coefficients, could you have thrown in the restriction of 1 on the lowest weight rather than dropping it?
You could. Oftentimes, I've tried that a lot, and my experience is it almost never does a thing. Never helps. Yeah. But you can try that as a last resort. Yeah. We created a new tool. Nobody's ever seen it before. I've never made a video for it, and I haven't tried it that much, so I hope it works. It's a new plugin. So just right here, Validity Master. Sort of like the Pattern Matrix Model Builder. Will it work? Come on. Please? Did it work? Maybe it did work. No, it didn't work.
Oh, your other screen, that gets up there.
Oh, maybe. Probably not. I don't know. Come on. Well, let me save it. Close it. Open it. I still need to work out the bugs. Obviously. All right, let's see. And up arrow. There it is. Standardized. Plugins. Please work. Validity Master. Yeah, it worked. Okay. So it creates this for you, and it flags the issue. Yeah, it's pretty cool. And it's the same stuff, just in 2 separate tables. And these are just HTML, so you can just copy and paste a word. And it flags the problem. So there are no problems unless they're in red.
Is that Validity Master plugin up on the thing?
No, I've never shown anyone this before. And it's not real stable, so I haven't put it out there yet. But you guys could do it the other way, right? Just using the video. No, I'll show you.
No, I can't do it.
You can't do the Excel version? Oh, why not?
I don't know, you ran it for me.
Oh, well then just do it right.
This is a Mac paste Excel.
Oh, yeah, Mac pasting.
Yeah, so
This would be really helpful. All right, if I have time between this workshop and the reception, which I won't, I could, it's not going to happen. I'll try to make a video soon. Monday-ish. Yeah.
Put that up and let us plug it in.
we're in CFA.
Will you email me? Just you, not everybody else. Will you email me and say, hey, please put this up? If it's in my Outlook, it will get done. Otherwise, I forget. Okay. Anyway, so we're at this point, and we see we do have a validity problem, which is spelled out right here. Convergent validity problem. The AVE for habit is less than 0.5. So that's a problem for convergent validity. But we saw that we couldn't really fix it by having that other item in or having it out. So what do? Do we chuck habit? What else can we do? We can keep it. We have 2 options, keep it or chuck it, right?
Well, plays on the model.
Okay, where does it play in the model?
Where does it play in the model and what's the theory behind it?
Ooh, ouch.
And it's already down to only 3 items, right?
Formative concept.
Okay, there's another option. Maybe it's formative. But for the capstone at least, assume everything is reflective. Because you really can't do much with formative in Amos. Or at least we haven't taught you, and I think it's not built properly for it.
So it'd be a problem to dump out habit because it's an interaction term.
It's pretty connected in our model. And at this point, here's what I would do. I would say it's salvageable. I'd say, yeah, sure, we don't meet the 0.5 threshold, but we're pretty stinking close. And look, we don't have any discriminant validity issues with it, and it meets the reliability estimate of 0.7. So it has discriminants, so clearly it's its own construct. It's not something else that we're measuring. It's just a little bit weak. So I would argue to keep it on those grounds.
Would you, but you know you're also going to use it for an interaction.
Yeah.
So if it causes issues with the interaction, then you might have to rethink that, right?
Here's what's going to happen. My guess, we're going to keep it, and it will have no significant effects. Because what are we measuring? We're measuring this mass, this muddy thing, and its effect on something clean. But there's no consistent movement within that construct. And so how can you say that a movement in this construct affects movement in this construct? This construct moves nicely together, whereas the items in this construct are moving slightly differently.
Don't you have a choice what to consider a moderator here? Because it could be the other thing having.
Certainly, you could. Yeah.
Can you just, again, explain why you choose this discriminant again?
Yeah, so it's discriminant because the square root of the AVE, which is on the diagonal here, for habit, this one, is greater than the correlations between the other constructs. It's pretty close, though, actually, on design expectations fit. That's troublesome. But it is greater than it, so it is discriminant.
James,
Yes?
you do not have this validity master yet in AMOS.
No, you don't. I haven't even made a video for it. I haven't told anyone about it. There's the Excel one. Use the Excel one. It works just fine. Unless, yeah, you're
It's
Ted.
not kind of that, it's in one chart, which makes it kind of easy.
Yeah. Okay. So at this point I say we keep it because it's discriminant and reliable. It might not be convergent, but it's really close. So that's executive decision. You guys can make a separate executive decision. In fact, if you wanted to drop it, that would reduce the number of hypotheses you have to test.
So, I see.
Well, no, that's wrong. The number of hypotheses you have to test, yes. The number of hypotheses you have to support is the same because you support your hypotheses before you test your hypotheses. So at this point, when you're theorizing, you don't know yet that it's not going to work, hypothetically.
So what would you say then if you had you would have that model first built, and you would have your hypotheses built around it?
And if you decided to drop it, you would, in real life, you'd probably just drop it from your theory as well, and not even bring it up, unless it was part of an existing model that you were building off of. And then if it was gone, it'd be like, whoa, what happened to that one? Because everybody knows it should be there. But if nobody knows it should be there, then it's just part of your exploratory theorizing.
James?
Yeah.
Just, Bernie and I had this question. He has a very, in some ways, a very similar model of mediation shown, but without, any direct paths from the IV.
Yeah, in the theoretical model, you don't show the direct paths from IV to DV. In the actual tested model, you do. So this is just theoretical. We're just saying these guys mediate the effects of these guys on these guys. But when you actually test it, you do try direct effects. Yeah. All right.
Well, why wouldn't you show that in this model?
We're just saying there's mediation. We're not saying how we're going to test it. In a mediation model, you don't have to show the direct effects unless you're also theorizing direct effects. Like you're creating a hypothesis for design fit on anxiety.
The reason I ask is that you have 10 or 12 or so hypotheses, and I see you got, you get that with you got that with 5 and 5 there, I see.
Something like that, yeah.
6 and 6, okay.
So when we looked at my theoretical model, it didn't have the direct effect.
Right.
But we had an article today by Judge.
Mm-hmm.
We did have it.
But he also probably theorized the direct effect as part of the mediation, is my guess.
The theory is that all of the independent variables are fully mediated by.
You can say, yeah, this the way it's visually drawn, this assumes or implies is the right word, implies full mediation. Yeah. Okay. I need to move forward. We're going to run out of time here. That would be tragic. Okay. So, we're good, is what I'm saying here. Problem is, we are doing some moderation, right? We're moderating by gender and frequency. Let me go ahead and do frequency. I'm going to create a group. Group, freak low. Freak high. And in the data, grouping variable, I've already created a freak cat, or cat freak. And this is in your capstone data too. So it's done. Okay, and cat freak group 1 is low. Capstone grouping cat freak 2. And that's just the high and low responses on those. And so we need to do invariance. There are 2 different ways to do this, the painful way and the easy way. I'm going to do the easy way, and you are allowed to do the easy way for the capstone. I need to write a paper on why it's valid still. I'll get to it eventually. Okay.
Can you slide that down just a little bit?
Oh, you don't see the top of my...
Didn't see that was the problem.
Oh. Let's see. Wow, you don't see a lot of it.
Can you show it again, please?
Show what again? Oh, you didn't see any of that?
No.
That's frustrating.
Will it be on the video?
It's all on the video. Yeah.
Guys, we're gonna run out.
Yeah, we're gonna run out of time. Okay, moving forward. Thanks for keeping me on task. Output, I want, critical ratios for differences. And I'm gonna run it. And here's the output. Let me go get my handy dandy Excel tool, wherever it is, stats tools package. Go over to group differences, and I need the regression weights table. You guys have seen this before, so it's not a big surprise. This one, not the standardized one, but the just regular old regression weights. Copy, paste, and I still haven't fixed it where you can do it with here and then switch groups. Now on FreeCai, copy, paste. I still haven't fixed it so you can do it with these missing labels. So I have to go ahead and get rid of these. So what we're doing is we're creating a z-score for the difference on path weights. Let me go get the critical ratios table.
How do we come up with these labels?
It's because we're constraining one indicator per factor. So one indicator per factor doesn't receive a new constraint. A label is actually a constraint. And so we end up with blanks.
You took those right out.
I just took out the whole row and shifted the table up.
Oh, I see.
Yeah.
The row had nothing in it.
Correct.
Thank you.
And click, please work. Yay, it worked. And so what I would do is then just see, this is for invariance, measurement invariance, not structural moderation. Measurement invariance, what we need to see is no significance here, right? Oh, yikes. Oh. All right. So here we have significance at the 0.05 is 2 stars. 0.1 is 1 star. I don't really care about 1 stars. I want to be a little bit lenient on invariance. And so these guys up here, not a problem.
Why is that?
Because it's at the 0.1 level, I want 95% confidence. And that's at the 90% confidence, which is too lenient. All right. Or in this case, too strict. But we do have problems. Skill acquisition 3 and 4. Those are different based on frequency of use, which actually kind of makes sense. And then design expectations fit 2. And so what do we do if we have 2 different? As long as you have one that is not different, you have what's called partial metric invariance. And I've probably cited it somewhere, I can't remember. Email me if you really need it. And there's an article about it. I think it's written by Williams and McKenzie or something like that. That says, as long as you're good to move forward as long as you have one that's not significantly different. And so one within each factor. So here's skill acquisition, the 3 items. One of them is not significantly different. So we have partial metric invariance on that factor. And that's the only one that scares us. Everything else is pretty fine. Habit has 2 that are not.
We could have 3, but
as long as there's one that's
not significantly different.
You're good. Yep. Okay. So we're good. What would you report? You'd say we met partial metric invariance. Moving on. Yes.
Aren't there any asterisks on the bottom on design for 4?
Because there was no significant difference. So this is a z-score to measure the difference, the significance of the difference between the 2 effects for low frequency and high frequency. Those frequencies were not terribly different, 649 and 796, pretty similar. And so we'd say not that different. Yeah, the threshold here is 1.96, roughly.
Would you delineate each one so you would say we met invariance with all factors?
Yeah, except skill acquisition where we had partial metric invariance. You could do that. Yeah. Okay, moving forward. Yay, invariance? Not that hard. What if you don't meet invariance? Here's what you do. List it as a limitation. When all else fails, say, this study was fantastic, except we were limited in that we didn't meet metric invariance. But we had configural invariance, so we're good, right? Configural invariance, do I need to show that? There's a video for it. All you do is you constrain it and then see if the model fit is roughly the same. If the model fit's still good. Yeah, there are some videos on that. I think I might.
Configural is the same as structural, right?
Huh?
So it's the same as structural invariance.
Well, structural invariant, yeah. Structural is a bad word because it has multiple meanings in this case. But yeah, configural means like the factors load all in the same, with the same items.
40 minutes.
No, we end at quarter after. Yeah.
Just as a heads up on Saturday, Tony's going to take us through the 8 different, the heterogeneity and
Oh.
the invariance in Brown.
Okay, great. So you'll get a thorough.
More than we would probably need.
Okay, yeah.
Is that fair?
Yeah, way more than you need.
Okay, so you do the 3 measurement model ones, and how many of the structural model?
You would just do moderation test in the structural model. Yeah, so you could do the same test, but in the structural model, and then you want to see significant differences. Yeah, we'll do that.
And in the variance?
The invariance, you just do that in the measurement level, measurement
You
model.
don't have to do the structural?
No, in the structural model, your invariance is actually moderation, which is good, right? Okay. Common method bias. I heard some of you had some headaches with this. Sorry, is that a sore point? I'm sorry. Okay. Here's what I would do.
It was an evilly sore point.
Is there a plugin?
If only. I'm thinking. It's my next plugin. Here's what you do. You know, do this really painful thing. We did not collect social desirability bias or another marker variable, and so we are not going to invent a marker. Podzikoff and McKenzie both say that inventing a marker actually does more damage than good. And so, in fact, they say using a common latent factor isn't that great either, but if you have to, go for it. But they say the only way to truly extract common method variance is through a marker variable, and the only marker variable that has ever demonstrated consistent success in doing so is social desirability. So assessing common method bias is actually a real flimsy thing, and doesn't have a lot of good statistical support. And so why are we doing it?
Something like expectancy.
Because you're getting a grade for it. I don't know. Because, well, in real life, you'll have a reviewer say, yeah, well, what about common method bias? You'd be like, fine, I'll do it to please the reviewer. So, we are your reviewer. And we're gonna say, what about common method bias? Okay. You don't constrain the path. Found that out the hard way, huh? Sorry, I made a video about it. I made 2 videos about it. The first one said constrain Well, there's a pop-up at the very beginning of the first video that says, I've made a different way to do this. Watch this video. It flashes. Come on. Yeah. If you have a pop-up blocker, it doesn't show up. Okay. Here we go. CLF. I think I also have to constrain the variance to 1. Save as CMB. We didn't save our invariance test. Oh well. CMB. And run. Proceed. And here's what we get is a bunch of stuff. What do we want to do with it? We want to grab the output. Grab the estimates, the standardized estimates here, copy. Actually, a few different ways we can do this. I'm going to show you this way. Here are the estimates, And let's just look at them real quick. Are they good? These are good. For EOU, we're good. For joy, we're not good. Look at these three. That's a problem. So we're having some common method variance extracted. Here, sorry, that's kind of small. There you go. So that's a problem.
0.5, right?
Yeah. Let's look down to anxiety is good. Usefulness is good. Skill acquisition, goodish. Habit is actually fine. You were good here. EOU. Ooh. That's a problem. That's a big difference. Joy is fine. What the heck? They're all negative. That's a problem. Usefulness. Ooh, man. We have some major issues here. Oh. Okay. Couple decisions we could make here. First decision. We go, yeah, cry. After you've cried. Are you kidding? Okay. Couple of decisions. Cry, and we could fiddle with it. I'm going to show you how to fiddle with it real quick, see if it works. I have never tried it on this model, so we're going to find out together. And if that doesn't work, I'll give you I'll give you the easy exit. Here we go. Let's see. So we have some major issues. If we go look at the output here, and we go look at here, the regression weights table, one thing we want to look for is ridiculously high standard errors. This column. These all look fine, yeah, except joy. Actually, these are kind of high. In fact, we have more error than we have estimate. That's pretty bad. Looking down, everything else looks pretty fine, actually. It's just joy. In fact, joy has issues, man. Joy 6 in particular. Here's what I'm going to do. I'm just going to fiddle. I'm going to first go to notes for the model. No errors here. So, joy 6. Where are you, joy 6? Right here. Okay. I'm going to put the path constraint on joy 6 instead of on joy 1. Is that going to work? I have no idea. And I'm going to run it. Proceed.
Don't you usually put it on the one that's closest related to the latent variable?
Yeah, the strongest loading, typically. Let's go look at the output. Estimates. Did that fix joy? Oh. Whoa. Actually, it did. I think. Wow. I wasn't expecting that. Hey, look at that. We're good. Oh, that's awesome. Hey, look at anxiety. Woo.
How do I write that up? It's like, I love it. It was so beautiful.
No. So here's what you do to write it up. You say, we did not observe common method bias. So why did this happen? Statistical anomaly. Put the constraint in one place, it's messed up, it can't calculate, it can't converge very well. Put it in another place, it's just more stable. It was an instability issue due to error. All right, but that actually worked. I can't believe that worked. All right, ease of use.
Let's try the same thing though.
Yeah. Okay.
Can you tell us what you do if it just doesn't work?
Yeah, we're gonna get to that point. Ease of use.
How would it be different if instead you constrained the
Let's do that for ease of use. Okay. Question is, what if we just instead of doing that let's do it for this one so you know we have a good comparison. So joy, instead of constraining the latent or the indicator, let's constrain the latent factors variance to 1. Let's try that.
Is the first one constrained with ease of use?
Yes, it is. I think so. Yeah. Okay. Output and estimates, and here we are on joy negatives. That's not what I wanted to see. So it makes a difference. Whoever asked that. I'm going to go put it back on Joy 6 because it makes me feel good. Let's see, Joy 6. Okay. And then for ease of use, let's find out which one has the highest error. Error, it's a weird word. Ease of use. I thought ease of use wasn't working. Looks fine. Joy is fine, fine, fine. I have ease of use twice? That's probably my problem. Oh, it's on, no, we're good. That's on the CLF. Oh, we're so good.
Wait, I'm sorry, what did you say?
This problem with ease of use is no problem. It's for the CLF.
Oh, I see, oh, yeah, okay.
So we're so good. In fact, let's go look down here. And do we have anything on the CLF that's really, really big? CLF, 6 on Joy 2. Joy still has some issues. Yeah. But if we go look up to here, we're pretty good. We're pretty good. If you wanna be real precise on this, what I'd do is grab the standardized regression weights, copy it over to Excel. Yeah, just do a delta between with and without the CLF. So let me go kill the CLF.
Wait, so if the answer were here that the CLF mattered, you just leave it in the model?
Now, one moment on that. Ask me that in just a sec, because that's a really important question that there are different feelings about.
Yes.
Okay.
Nothing more than feeling?
Nothing.
Opinions?
Strong.
I was running out of the song.
Why aren't we? There we go. And then here. All right. So here is with CLF. CLF. Okay. There we go. And we'll just get the difference equals this minus this. And if there's anything greater than 0.2, we have some issues. Here's one with Joy 2 and Joy 4 and Joy 3 and Joy 1. So Joy is, we're going to talk through this. Just say, we're good, useful. Okay, that's really, okay. So Joy seems to be a common thing. Now, if we think about our constructs here, ease of use, anxiety, usefulness, skill acquisition, habit, and design fit. Could joy be an underlying thread in any way? Could it be just strongly correlated? Is that the real problem? Are we just detecting a strong correlation between them? Here's one way to tell. Go to the correlations table. Correlation. Here's joy. It actually has pretty strong correlations. If you compare these to the other correlations, like here's ease of use. Not as strong as with joy. Look at all those. Other ones, usefulness. Usefulness was the other one we saw we might have an issue with. Usefulness is strongly correlated. Does that mean it has common method variance? Hard to tell. So, what would I do if I decided, yes, I do have a common method bias problem? If it were like this, and my loadings were still sufficiently strong, I would just leave the common latent factor in there. If it was warping my my loadings like it was before we moved that constraint, and I was getting like negatives and zeros, I would take the easy way out and say, according to Podzikoff and McKenzie, common method bias is not estimatable, it's not extractable, unless you have a measured, intentional common method bias marker variable. And so to pretend that we can extract method variance using some common latent factor is just deluding ourselves. And so I would not even include a common latent factor. I would just proceed.
So for the first option there, let's assume for a sec that the common latent factor still matters.
Yeah.
So you keep it in there, step it ahead a little bit, but you will impute the values.
Yeah, let's do that right now.
Into your construct. And then from then on, it will receive its partial variance.
It's already in there.
For your SEM,
it's not. It's imputed with everything else. So with this model, I'd say yeah, let's leave it in, because we have a few minor issues. We could also argue it out, honestly. So I'm going to go ahead and save that, and analyze. Oh, I didn't leave it in. Bother. And I just saved. For this model, we're gonna not. We're gonna argue it out. You operate the exact same way. And I recommend, for a model as complex as this one that we're testing, do impute composites. Don't try to do this as a hybrid model, because once you start doing interactions, it just gets to be a disaster. All right. Data imputation. Oh, bother. Model fit. You guys know how to do model fit?
Yep.
So I will spend half a second on this just to see if the model fit is good. Good, almost, and good, actually. So the only thing is a CFI.
Where do we get SMR?
SRMR, plugins, standardized RMR, run it. And there it is, 0.0728. It should be less than 0.08, so we're good. So the only thing was that CFI, which we could address pretty easily using the modification indices. 30 to 31 and 18 to 19 will probably do it. 30 to 31 and 10 to 11. 18 to 19. Ooh, where'd 19 go? Right there. And yes, 30 to 31.
In terms of significance on the CFA level.
Look at that. Sorry, I'm listening.
Less than 0.05, right?
The p-value should be greater than 0.05.
Greater than.
Yes, but you never will reach that. Not with this model. We have too many variables and too much data. CFI bumped up quite a bit. We could do it more. You know how to do that. I'm not going to spend time iterating through that.
We had a discussion just this afternoon about if you covary error terms, and you, unless you say how you're doing it, you're just kind of pointing and shooting.
You should say why you're doing it. The standard response for the standard justification for doing it within a factor is just there's conceptual overlap. These are multicollinear items intentionally, and so it's right that they should covary.
Just say again how you chose those.
Yeah, I looked at the modification indices, and they were really high. The ones that I covaried. They're gone now, because I covaried them. So the next one I would do is like this one, 20 to 22, very high.
What's very high?
Higher than everybody else.
Stick out.
Yeah. All right. Okay. Next, we impute, analyze, impute, and hit impute. If it doesn't work, two. Why'd you create two? Because I have two groups. That's why. So before you impute, get rid of, deleted, right, no, double click, delete. And for this one, it's just default. Close and make sure you get rid of that grouping variable. No variable. Back to 300 responses. And run. Also, you should be doing model fit on the full model, not the moderated model. Okay. Then we run analyze data imputation, and I'm going to change the file name here to workshop C. Actually, that's fine. Save, impute, okay, and close, and new, and yes, and open the new data set, which is C. And okay. Okay. We're at the moment of truth to test our basic model. Now, the way you test this is up to the way you theorize. We have very little time and a very complex model. Here's what I would do if it were me. I would theorize two hypotheses with 3 parts each, right? Perceived ease of use mediates the effects of on do. That's actually more than that. It's like a 6-part hypothesis. So, and then do the same for perceived usefulness. So you have 2 6-part hypotheses, A through F or G or whatever that is.
So one of the hypotheses includes, or not one, but for each of these, the interaction effect is also hypothesized?
Not yet. No.
Okay, all right.
So my first hypothesis would be something like perceived ease of use mediates the positive effect between design expectations fit and joy in use. A. That's H1A. H1B would be the negative effect between design expectations fit and computer anxiety is mediated by perceived ease of use. And then C to E. Well, that's just A, B. You could do 6 hypotheses with 2 parts each. That would work. Something like that, however you want to structure it. Then, we're done with mediation. You test mediation, you push that aside. Then you do moderation. Well, you theorize it and theorize it and theorize it, and then you test. But the moderation, it would be something like design fit. As design fit increases, the effect between habitual use and perceived ease of use strengthens, or something like that. And that's the only part of that interaction you test. You're not going to do the mediation of the interaction to the dependent variable. That's like mediated moderation. Yeah, don't do mediated moderation. And definitely don't do mediated moderation moderated by gender. I mean, that's mind-breaking. So do them in pieces. So you have a few interaction hypotheses you can test separately from all this mess. And you're not going to do it when splitting by frequency or gender.
So you're done, you won't be testing individual models though with...
You'd throw all this in for the interaction test. But for the mediation tests, I would not have these interactions present. Just don't even worry about them when you're testing mediation.
I'm sorry, going back to the moderators.
Same with the groups for frequency and gender. Don't have the interactions present. Have the interactions be the very last thing you throw in there. Yes.
And then the controls seems like the diagram gives you, in principle, a choice where to apply them. And you just
apply them at all times.
No. I mean.
Where to regress?
Yeah. Can you regress into like one of the last variables as opposed to the mediators?
Yeah. Here's what you would do. There are 2 different ways to do this. One way is theoretically, which is the right way, and that's where you say, well, what should education confound? What is education really going to affect? I think it will affect anxiety. Yeah. Same with age. I think that'll affect anxiety. Experience probably affect joy and usefulness and ease of use and anxiety actually. And so you can regress on whatever you think is theoretically going to need to be controlled, or control for it on them. Or you can just look at the modification indices and see what it really does have a statistical correlation with. That's the wrong way. But you're going to run modification indices anyway, and then add the path. So, chicken or the egg. All right.
Going back to the moderators.
Quickly.
When do you want us to add those? Do you want us to add them with the interaction terms, or?
No. You do the interactions on their own with just this model. Forget the multi-group moderators.
Right.
Yeah. I have another piece of advice. You don't have to test everything in this model. This is an exercise, right? So do you have to test every single mediated path that we see here? Pick a few. What are we trying to figure out? We're trying to figure out if you know how to formulate a hypothesis and support it logically, and then test it. And then garner insights and apply them to the real world. That's what we're trying to test. We're not trying to see if you know how to do busy work and test 50 hypotheses. So pick a few. Are we going to argue with you? No, you're mature adults. You make good decisions.
So to that point, so when we're doing the multi-group, we're picking frequency or gender.
No, pick both. Okay, thank you for the clarification. You do need to do moderation by both moderators separately, not frequency and gender simultaneously. But let's say we don't want to hypothesize about this path being moderated and this path being moderated and this path being moderated. I don't want to theorize about all that. So pick 2 of these paths to be moderated by groups. Don't do all the mediations. Pick a few, but do mediate through each of these and to each of these, just not all of them for everything.
So you might say what your hypothesis might be, perceived ease of use is moderated by gender. Computer.
The effect between perceived ease of use and computer anxiety is moderated by gender, such that it's stronger for males.
Okay.
And that's your moderated hypothesis. Maybe pick 2 per.
So you're mapping one item to the other item with the moderation versus
Yeah.
getting into all the IVs.
Yeah, because if you'd have to theorize about all that. And that, I mean, you'd have a 1,000 page. It'd be like the tax code. Yeah.
Why can't you theorize that they're actually the same, like you do like in anonymous?
We don't theorize no effect. So that means there's no effect from the moderator, right?
Yeah.
That's the null hypothesis. We never theorize the null hypothesis except in some other fields. In more behavioral organizational fields of research, we don't theorize null.
Well, the only reason I suggested this is that you can just see which paths are different.
You could do that too. However you want to roll it. We want to see that you know how to theorize and you know how to test what you theorized
So just to confirm.
on those various analyses, those various structures, mediation, moderation, including controls, interactions. Yes.
We'll set up a couple of moderators, frequency and gender. Pick some for frequency, pick some for gender, we're done.
Yes. Correct.
You said 12 to 15, right?
It's probably about right.
That's gross hypothesis.
Yeah. They might have multiple parts. We'll see. It's your call. As long as you justify it and we agree with you, then you're good. Yes. I guess we're just down to questions now.
So let me,
But you guys have seen mediation and moderation so many times, and there are videos for them.
so we don't need to do a moderated mediation.
No. Ugh, no. Can you imagine theorizing about that? It's just a pain in the rear.
So for the multi-group moderation, you just want us to compare one group versus the other group for the entire model, not...
So you could do it for the entire model, or you could pick some paths and theorize about how those paths will differ,
Got it.
and then test those paths.
Got it, I misunderstood you.
Okay.
What are the biggest mistakes around interaction?
Yeah. A couple of mistakes around interaction is misunderstandings around interaction. You don't have to trim out everything that's not significant. You can leave it all in. Although trimming things out that are not significant helps sometimes strengthen the interaction effects. Oftentimes interactions are not significant. Very, very often they're not significant. What should you do if you don't find any significant interactions? You're still theorizing about them. You say, we didn't find any significant interactions, but here are the plots of the slopes. And use that interaction plotter that I have in the video for it. And say, even though this isn't a significant interaction, there are clearly different slopes here, and this is what I think it means.
So if you can have, let's say the first one, DF and X and HU, okay? Let's say that's significant. So is design fit and habitual use and skill acquisition. Let's say you just have those.
Yep.
Let's say all of those are significant going to perceive these reviews.
Okay.
Does that mean that I can hypothesize, that I can hypothesize that there are,
You hypothesize first, then you test those.
okay, then it would be supported then,
Yes.
okay, if how can I say this? Not well, anything significant we can use, regardless of whether or not it makes up one of the interaction pairs. And it's going to the same path.
I don't think I understand the question.
Yeah, I'm sorry.
Formulate it.
Yeah.
Any final questions? We have 5 minutes. I can still show you stuff if you want, or I can just answer questions. Here's what you would go through. Let's talk through steps. You do model fit. When do you do model fit? Only on your final models. So for the CFA, whatever your final after modification indices, after you've tested for invariance, after you've tested for CMB, you have to go back to your whole data set model, not split for invariance, and fit it, and then report that model fit. The model fit of the model you're going to impute to create those composites. That's the model fit you report once. Then you report model fit for your structural model. When? You could actually do it multiple times for the structural model. Since you have multi-group moderation, you might report it for, well, except when you're moderating by gender, when you're moderating by frequency, and then when you include the interactions. So that'd be potential of 3 different times. You could just do it once for when the interactions are in there and there's no moderation going on. That is probably a better solution, actually. Yeah. So you'd have 2 reports of model fit, one for measurement model, one for structural model. Yes?
I asked this before, but since you're doing interactions here, you're going to be transforming at some point to test interactions, right? And at least in the examples we followed, once we do that, we transform everything that we're testing in the model.
Okay, good question. The way regressions work, you can actually just standardize and multiply those 2 variables, the moderator and the independent variable together, and then just use that product variable, stick that back in your original model. Nothing else needs to be standardized. It doesn't make any difference in the regressions. The estimates will be identical. Or I could use all standardized ones and they'd still be identical. It's just the way the regressions work. It's just relative changes in distance. So what should you do? Honestly, it doesn't matter, but I would just keep your model and then stick in the 2 or 3 interaction variables. Yeah, everything else nothing else has to be standardized. Yeah. Okay, so you'd go, and in what order would you test all this? In the order you theorize it. My recommendation, theorize mediation, multi-group moderation, interactions. And that is also how you will test it and then how you will report it in that nice clean structure. You theorize it in that order as well, but you theorize everything and then you test everything and then you report everything. Controls the whole time. Just keep them in there. What do you do about them? You discuss theoretically why you included them in the first place. Like, unluckily for you, I chose these controls, so you have to just try to figure out why I included them. Just make something up. It's just got to be logical. And then discuss briefly any interesting effects from your controls. Couple sentences. If there were significant effects, mention them. If there were only significant effects for one control, for one group, mention that. If, for example, age only mattered for women on joy in use, explain that and explain why that actually makes sense, actually, or something like that.
So you said mediation, multi-group, and interactions.
Yep, that order is my recommendation.
Not moderation.
Definitely do moderation. Don't do moderated mediation or moderated mediation.
So force moderation.
I'm sorry?
You say theorize,
yes.
First mediation, then second.
Mediation, then multi-group moderation, then interactions.
Or you take out the moderators from the interactions.
Yeah, I would take out the grouping moderators when you do interactions, definitely.
And take out the mediators?
And on mediation, whoa, one last thing, haha. On mediation, I cover this in my SEM series video on mediation, but we have 2 mediators here. That means we have multiple indirect paths from each IV to each DV. That's a problem if you're theorizing perceived ease of use mediates. Well, in fact, we're testing both at the same time. So what you have to do is delete, let's say we're doing design expectation fit through this to this, I have to delete that path right there. And then I only have one indirect path. And then put it back in, don't forget to put it back in. Otherwise, the indirect effect you estimate is actually through both mediators. Yeah.
Video does a great job of showing that.
Oh, good.
It's really, really easy to follow.
SEM series mediation.
And it's on Staff Wiki, right?
I don't know if it's on the stat wiki.
It's on YouTube.
It is.
Yeah.
It's definitely on the YouTube. It's called the SEM series on mediation. Okay. Any last question?
The way I
I
find
got
it
this
is,
question.
Okay.
type mediation cascade, and it pulls that.
Yeah, SEM series, Gaskin mediation. You're good.
I don't do all that. Just
Okay.
type mediation, cascade.
I have a few on mediation. That's why.
Oh, okay.
Yeah.
When to bootstrap?
Whoa. When do you bootstrap? When you want to calculate the standardized indirect effect for mediation. That's the only time you need to bootstrap is mediation. Yes, and then you.
We went through, I have here a capstone from an Indian guy. Then
Oh, Shams.
exactly. When you are speaking before about passes, this is point 6 regression using SPSS and then create interaction terms. About the path modeling, when you do structure equation modeling, that's what you have just explained.
This is a path model,
Exactly.
which is part of structural equation modeling.
So you delete, if you will.
Oh, on interactions, you could delete paths that are not significant. I have a video that explains the very intricate process, but typically, essentially, if this interaction has a significant effect on ease of use, I cannot delete non-significant paths from either of its constituent variables. So like, I couldn't delete this path right here or this path right here.
Even if it were insignificant.
Correct, because the interaction effect is significant and I need to control for those things.
Same.
Apologize, he calls that use path significance and R-squared values to guide any path modification
Yeah.
you might pursue. That's
Yeah.
what you just explained.
Yep.
Thank you.
Yep, don't forget to report R squares. Those are important. That too.
So let's just say again, design fit, habitual use, skill acquisition are all significant.
Yeah.
But habitual use interaction with skill acquisition not, so we can trim that out. But I want to be able to use interaction effect between skill acquisition and design fit against DF and HU.
Uh-huh.
Can I do that?
DF and HU.
Yeah. Design fit.
You just said SA and DF. I don't think I understand your question.
I'm sorry, I'm trying to make it more complicated.
Okay.
Design fit, the first three.
Yeah.
Let's say they work.
Yeah.
okay? The next one doesn't.
Yeah.
The one after that one does. But can I put into the interactive slope
Thingy.
thingy, interactions between skill acquisition, habitual skill acquisition, habitual use, and DFHU? Even though skill acquisition is not part of DFHU.
No, that doesn't make any sense at all.
Okay.
Okay.
I can show you my homework because you got it passed on and I wasn't sure.
Okay.
James, one last question.
Yeah.
What's the paper reference about how to standardize?
It's McKenzie and Podzikoff, 2012, I believe.
2012.
Yeah, I think so.
We did one together in 2003.
Yeah, no, there's a new one. I forgot one other thing. I didn't really forget, but here it is. Multivariate. These three, I so don't care about these three, but we'll probably check for them. But the answer to all of them is, well, they might affect, they might not affect your model, and there are different schools of thought out there on them. I have videos on these, how to do them. Feel free to, and also my example analysis explains kind of how to do it. But the answer is, if you run into problems, there are schools of thought out there that these don't actually matter, especially if you're moderating. So it's an exercise. Yeah, anyway. But your executive decision, if you run into problems here, is, well, schools of thought say it's probably all right, actually. Okay, we're good.
Thank you.
Woo!
James,
You're welcome. I get applause.